Orthographic projection is one of the most important part of the engineering drawing. Almost every part drawing we prepare is in the form of orthographic projection. And today, in this video, we will be discussing multiple choice questions on this topic. And more focus will be on orthographic projection of point and lines. So, let's take a first question. To represent an object on paper by first angle method of orthographic projection, the horizontal plane, that is HP, should be placed in which way? And options are A. HP is placed to the left side of VP, that is vertical plane, and parallel to it. Option B. HP is placed to the right side of VP, parallel to it. Option C. HP is turned into anti-clockwise direction up to 90 degrees. And option D, HP is turned into clockwise direction up to 90 degrees. To answer this question, one must know what is first angle method of projection is. I have made a separate video on it. If you want, you can watch that video. I will provide a link in the description below. Let's have a quick look on a first angle method of projection. Here, we have an object which is a rectangular slab placed in a first quadrant in a space. Object is surrounded by a vertical plane, horizontal plane and two profile planes. And in order to bring all planes on a single plane, like a flat sheet of paper, we rotate HP in clockwise direction by 90 degrees, like this. And profile plane also turn into outward direction by 90 degrees like this and this. So now we can see all planes are on a single plane. So now we can choose a correct option and it is D. HP is turned into clockwise direction up to 90 degrees. Let's take a next question. In first angle projection, the front view is above the top view. Is it true or false? And answer is true. We know that after we bring all planes on a single plane, like we just did in previous explanation, then the position of views becomes this. And here we can see that front view lies above the top view. Right hand side view is to the left of the front view and left hand side view is to the right of front view. Let's see the next question. Which of the following is the symbol for first angle projection method? Dear friends, the symbol of first angle and third angle method of projection is derived from the front view and left hand side view of a frustum of a cone. Let's see how. Here we have a frustum of a cone, means a part of a cone without an apex. And if we draw its front view looking in this direction, then it would be like this. And if we draw its left hand side view looking in this direction, then it would like this. Two concentric circles. And as per the first angle method of projection, left hand side view falls to the right side of the front view. And this is the symbol of first angle method of projection. And according to the third angle method of projection, left hand side view falls to the left hand side of the front view. And this is the symbol of third angle method of projection. So the correct option is D. Now next question is, in first angle projection, the right hand side view is to the left of front view. And answer is true. Next question. A point is in first quadrant, 30 mm away from the horizontal plane and 20 mm away from the vertical plane. Orthographic projection is drawn. What is the distance from point of front view to reference line and top view to reference line? And options are A. 20 and 0 mm. Option B. 30 and 20 mm. Option C. 20 and 30 mm. And option D. 0 and 30 mm. Alright. Let's try to visualize this condition first. Here, point is 30 mm away from the horizontal plane and 20 mm away from the vertical plane. For a front view, imagine that you are looking in this direction, and in front view you can see how much distance point is above the HP, and here it is 30 mm. And if you imagine you are looking from top, then you can see how much distance point is in front of VP. And this common line of both HP and VP is called as a reference line. So, distance of front view of a point from reference line is 30 mm and distance of top view of a point from reference line is 20 mm. So, correct option is B, 30 and 20 mm. Now moving on to the next question. A line of 50 cm length is perpendicular to profile plane and the least distance of this line from profile plane is 7 cm. This is at a distance of 5 cm from vertical plane and 6 cm from horizontal plane. What is the distance from the line to the XY reference line in top view? And here are the options. In order to answer this question, we need to visualize a line placed in a first quadrant with horizontal plane, vertical plane and profile plane. So let's do it. Here we have a line of 15 cm length whose one of the ends is 7 cm from profile plane as per given. Also, it is given that a line is 5 cm in front of VP, which we can see from top view. And line is 6 cm above HP, and this we can see from front view. Here question is, what is the distance from the line to the XY reference line in top view? And the distance of a line from XY line which we can see in top view is 5 cm. So correct option is A. Now next question. A line of 150 mm length is parallel to vertical plane and makes an angle of 35 degrees with horizontal plane. The length of a line in top view is dash dash mm. And here are our options. To find out length of a line in top view, we must know how the front view and top view of a line will look like under given condition. And visualization is a key. In the given statement, line is parallel to VP, so we can assume that line is on the VP and inclined to HP at an angle of 35 degrees. Here, true length of a line is known, which is 150 mm, and angle of line with HP is also known, which is 35 degrees. And what is asked to find out is the length of a line in top view, which is also called as plan length. Dear friends, this 3D diagram makes you imagine the position of line in first quadrant, but that's not what you're supposed to do while you solve the problems of a line. What you should do is draw front view and top view of a line on a paper and then find the required answer. So now let's see how to put this on a paper. As you look at a line from front view, you can see the true length of a line which is inclined at an angle of 35 degrees with the horizontal reference line. So simply draw front view of a line by drawing a line of a length 150 mm with an angle of 35 degrees. And then draw a top view of this line. And to do that, take projector from each end points in downward direction. And as line is on the VP, from top view, line will appear as a straight horizontal line. Draw a horizontal line which is the top view. All done. If you do this with exact dimensions, then you can measure the length of a line in top view, which will become 122.87 mm. and it is known as plan length. So correct option is A. But wait, for MCQ type of questions, we don't have to draw it with exact dimensions because it will take more time. So you just draw it without actual dimensions, means roughly, and then try to find out unknown by using the trigonometry. And here we need to find out this length. And we can easily find it out by using a formula. Cos 35 is equal to adjacent side upon hypotenuse. And then we will get a length of a line in top view, which is 122.87. Alright, let's take a next question. A line of 80 mm length is parallel to horizontal plane and makes an angle of 47 degrees with vertical plane. The length of a line in front view is dash dash mm. And options are, here as line is parallel to HP, we will assume it as lying on the HP, and line is inclined to VP at 47 degrees, and this inclination is visible in top view. We need to find out the length of a line in front view. We have seen in the previous question that how to deal with this type of problems. Yes, by using trigonometry. So here we have a right angle triangle whose hypotenuse is 80 mm and angle is 47 degrees. So to know the length of a line in front view, we can use a formula cos 47 equal to adjacent side upon hypotenuse and calculate the adjacent side, which is nothing but a length of a line in front view, which is also known as an elevation length. And you will get an answer which is 54.56, which I have already mentioned. So correct option is C. But still, if you want to see how you are going to do this on a paper quickly, let's say it. Here you need to draw a top view of a line by drawing a line of a length 80 mm at an angle of 47 degrees. Of course, draw it roughly and quickly. Then draw a front view of a line which is straight horizontal line. And here you can apply a trigonometry formula to find out a length of a line in front view. Very easy. Now let's look at the next question. If a plan length of a line is 50 mm and true length is 100 mm, what is the angle made by the line with HP? Here are our options. Plan length is 50 mm and true length is 100 mm. Here we have to find an angle made by true length with HP. So first draw a true length of a line inclined to HP. However, this angle is unknown, but we know that the length of this line is 100 mm. And then we know that if we see true length in top view, then what we can see is plan length. So take projectors from front view to draw top view of a line and draw a straight line showing top view, which is a plan length, and this is given as 50 mm. Here, if we look at this right angle triangle, then this adjacent side is having a length which is same as that of plan length equal to 50 mm. Now to find the angle made by line with HP, use trigonometry. Cos theta is equal to 50 upon 100, and by solving this, we will get the value of angle theta, which is 60 degree, which is in the option B. Next question. A line of 90 mm length is inclined to vertical plane at an angle of 50 degrees and parallel to HP. The length of a line in top view is dash dash mm. Here are the options. A line of 90 mm length means here true length is 90 mm and this true length is inclined to VP at an angle of 50 degrees. Inclination of a line with VP is visible in which view? Yes, right, in top view. So here we can draw a top view of a line inclined at an angle of 50 degree with horizontal. Now to draw front view of a line, take projectors from each points of a line in upward direction. Then draw a straight horizontal line which shows a front view. And this length of a line in front view is called as an elevation length, as I told you earlier. But wait, do we really need to draw this front view? Once again, let's see what is asked in the question. And it is, how much is the length of a line in top view? And here we can see that the length of a line in top view is 90 mm. So why the hell I have drawn the front view? It wasn't needed at all. But what if in the question it is asked to calculate the length of a line in front view? Then you must do this and find out the length of a line in front view by using trigonometry. Alright, dear friends, sometimes you can have the answers of some of the questions without drawing front view and top view. You can answer them just by imagining the given situation of a line and apply a logic to answer those questions. But yes, it depends upon the type of question. Like in this question, one can answer it without drawing any single line. Try it. Well, now let's take another question. Which statement related to following figure is true? And here are the options. Here, front view of line AB appears as a point. Means line must be perpendicular to VP. So correct option is C. Next question. Which statement related to following figure is true? And these are our options. Here, length of a line in front view and top view is same. Means line is parallel to both HP and VP. So correct option is C. Next question. Which of the following statements related to following figure are correct? First, line AB is on the VP. Second, line AB is on the HP. Third, line AB is 128 units above the HP. And fourth, line AB is 128 units in front of the VP. Well, let's look at the front view first. Front view of a line appears on XY reference line. Means line is on the HP. So second statement is correct. Now let's have a look at top view of a line. And we can see that line is 128 mm away from XY reference line. Means line is 128 mm in front of VP. So here fourth statement is also correct. So the correct option is option D. Next question is, which of the following statements related to following figure are correct? And here are the options. First, line AB is on the VP. Second, line AB is on the HP. Third, line AB is parallel to HP. And fourth, line AB is parallel to VP. Here, take a look at a front view. We can see that front view of a line appears on XY reference line. So line is on the HP. And as line is on the HP, it is parallel to the HP. So second and third statements are correct. Now take a look at top view. Top view of a line also appears on XY line. Means line is on the VP. And as line is on the VP, it is parallel to the VP. So first and fourth statements are also correct. It means all statements are correct. So correct option is D. Now next question is, in following figure, line AB is 88 mm above the HP. In front view, we can see the distance of a point above the HP, and in top view, we can see the distance of a point in front of VP. With this, we can say that in the given figure, line is 88 mm above the HP and line is 0 mm in front of VP means line is on the VP. So answer is true. Alright, next question. In the following figure, 35 degree is dash dash. And here are our options. In this figure, front view shows a true length of a line and top view shows a plan length of a line. So angle 35 degrees is the angle made by true length. But with which plane? In front view, we can see the angle made by the line with HP. And in top view, we can see the angle made by the line with VP. And as here, this 35 degrees is the angle visible in front view. So it is the angle made by true length with HP. So correct option is A. Note one more thing. The angle of true length with HP is generally denoted by theta. Alright, let's move on to the next question. In the following figure, 123 mm shows dash dash. And here are the options. Here, 123 mm is a length appearing in top view, so it may be a true length or a plan length. But if you take a look at front view, then you will notice that the true length of a line is 150 mm and length of a line in top view is not 150 mm but shorter than that. So this 123 mm is plan length. So plan length is a length which appears in top view, which is not a true length. And hence correct option is B. Next question. In the following figure, the angle 35 degree is generally denoted by dash dash. And options are, in one of the previous questions, we have seen that angle made by true length with HP is denoted by theta. And in this question, figure shows the angle made by the true length with VP, which is 35 degrees. And generally, we denote this angle by phi. So the correct answer is C. Dear friends, remember that theta is the angle made by true length with HP. Phi is the angle made by true length with VP. Let's take the next question. Which statement related to following figure is true? Options are, in this figure, top view of a line appears as a point. So in this situation, line must be perpendicular to the HP. So correct option is B. Next question. A regular cone is rested on base on a horizontal plane. The front view will be, and here are the options. If a cone is resting on HP and we are looking at the cone from front view, then it will appear as a triangle. More specifically, it will appear as an isosceles triangle. Hence, correct option is D. Let's see next question. In the following figure, 123 mm shows dash dash and options are, alright, ask yourself the length of a line appearing in front view, is it a true length? No, it's not, because the true length of a line is actually appearing in top view, which is 150 mm. So the length of a line which appears in front view, which is shorter than true length, is known as an elevation length. So correct answer is C. Remember, a shorter length which appears in top view is called as plan length, and a shorter length which appears in front view is called as an elevation length. Dear friends, this was the last question of this video. We'll see you in the next video with some more MCQs. Till then, take care and happy learning.